Hello everybody, in this video I'll be introducing you to some other trig functions that you'll see and just sort of talking about trig functions and stuff like that. So let's jump right in. Alright, so I'd like to start today by introducing you to SOHCAHTOA, and you might have seen that in the background of my last video. But basically what this is saying is that S, which stands for sine, equals O over H. So you just write that so, and then cosine equals adjacent over hypotenuse, or CAH, C-A-H, and tangent equals opposite over adjacent, or you can just write TOA for TOA. So this is one way you can remember sine, cosine, and tangent, and what they mean. So let's take a very common trig function, sine of theta. If we input theta, we'll get the opposite side over the hypotenuse. Now with inverse sine, we're going to input opposite over hypotenuse, and we're going to get theta. So, see where this is going. So I have a triangle right here. And let's try to find angle O and angle L. Let's start with angle O. So if angle O is theta, 16 is the opposite side because it's opposite of angle O. And 17 is the hypotenuse. So when O is equal to theta, 16 is equal to the opposite side because it's opposite of angle O. And 17 is the hypotenuse, and always will be because it's opposite of the right angle. So what trig function deals with the opposite side and the hypotenuse? Well, sine. Except remember, we're trying to find angle O, so we can use inverse sine of 16 over 17 will give us angle O. Angle O. Now, if you punch that into a calculator, you should get angle O equals roughly 70.25 degrees, just about. And I'll just round that to the nearest degree. So we have this angle equals roughly 70 degrees. Now, what about angle L? Well, there are two ways to solve this. The first way is taking 180 and subtracting 90, then subtracting 70, which will give us 20 degrees, but it was 70.25. So really we get 19.75 degrees, but so the angle L should equal 19.75 degrees, but let's double check with doing what we just did. So if angle L is theta, 16 would be the adjacent side because it's adjacent to angle L and the right angle. And 17 is still the hypotenuse because it's opposite of the right angle. So now we can input. So we can input into inverse cosine 16 over 17, which will give us angle L. And if you do that, you will get 19.75. So angle L equals 19.75 degrees, and round it to the nearest degree, and we get roughly 20 degrees. And now just to finish solving this right triangle, why don't we just solve this side right here? And let's use the hypotenuse this time to solve it. So there are two ways we can solve this. We can treat 20 degrees as theta or 70 degrees as theta. Either one will work, but we have to make sure we use the right trig function. So if we're treating 20 degrees as theta, then we have to treat this trig function as sine. If we're using 70 degrees, we have to use cosine. Let's just use 70 degrees for fun. But let's use 70.25 degrees to be a bit more exact with our answer. Alright, so now we have the cosine of 70 degrees equals the adjacent side over 17. So if we multiply both sides by 17, These cancel each other out. And now we have the adjacent side equals 17 times the cosine of 70 degrees. So if you enter that into a calculator, you should get 5.74. And if we rounded that to the nearest tenth, we get 5.7. If we rounded that to the nearest 1, we get 6. So we've completely solved this right triangle. Angle L equals 19.75 degrees. Rounded to the nearest 1, it equals 20 degrees. This side equals 16. This side, or the hypotenuse, equals 17. This side equals 5.74. And this angle equals 70.25 degrees, or rounded to the nearest 1, we get 70 degrees. So this triangle is completely solved. Yippee! Let's talk about reciprocal trig functions. So the reciprocal of sine is cosecant, which equals 1 over sine theta, which equals the hypotenuse over the opposite side. And secant is the reciprocal of cosine, which is 1 divided by cosine theta, which equals the hypotenuse over the adjacent side. And cotangent equals 1 divided by the tangent theta, or just it's the reciprocal of tangent, which also equals the adjacent side over the opposite. And because the tangent of theta equals sine of theta divided by cosine of theta, cotangent equals cosine of theta divided by sine of theta. Thank you so much for watching. If you enjoyed this video, please give it a thumbs up and subscribe to my channel and hit that notification bell. If you dislike this video, please share with somebody else because they might find it helpful. But for now, goodbye.